Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and today we're continuing with our series for the PCEP, the Python Certified Entry Level Programmer. And to do this we're going to be taking a look at casting in Python. So when you're ready, sat comfortably, we shall begin. Casting can be implicit or explicit. We're going to begin by taking a look at implicit casting, which is also known as coercion. So to be able to see this, I've moved to my Jupyter notebook. And why don't we go through and do a simple arithmetic operation? If we go through and try adding an integer 5 through to a float 5.0, the integer is going to be implicitly cast through to a float. So they can be added together. Our result is going to be a float of 10.0. So this is our first operation where we can see the implicit or coercion. You can see something similar by looking at floats and integers in comparison. So if I go through and have a simple variable, we'll call this is equal. And the variable is equal is going to be the result of 5 is equal to 5.0, an integer compared to a float. When we look then at what's stored in is equal, we can see that it is true. 5 does equal 5.0. Technically it doesn't, but the casting took place before the comparison. So 5 became 5.0. Another area where we can see our implicit casting working is with Boolean expressions. If I use if 0, well 0 is an integer, but it could also represent false. So it will be cast implicitly to false. In this case, if false would print absolutely nothing, because, of course, the condition is not true. So we can see in our print method, we're saying we will print nothing because 0 is cast to our Boolean value of false. So executing the cell, and indeed nothing happens. But if we change it slightly, well, we go through and put if and then integer 1 is going to be cast through to Boolean true, so the result will be printing out. And we can put a message to that effect. This will print because we're reading if true. 1 is cast to the Boolean value of true. Let's give this a whirl and check that it does work. And truly, as we said, it does now print. So this is our implicit casting. So the second method of casting is where we explicitly cast ourselves. So let's go through and take a look at how we can do this. Moving back through to my Jupyter notebook, we can go through and look at, rather than allowing the system to coerce or implicitly cast our numbers, we can make sure they are cast to the correct values before anything happens. Remember, explicit is better than implicit. So I can have my number being assigned the value of 5. I can check its type at this stage by checking type number, and of course it's going to come back as an integer. But if we continue, we can go through and reset our number equals the float or explicitly casting number. So we're converting it now through to a float ourselves. Now when we go through and take a look at the type of number, it should report back that it is indeed a float. Let's go through and take a look at this, executing our cell, and we can see then that we get the last evaluation coming out of our type being number. But of course, this is just using simple in Jupyter. So let's go through and explicitly print out the values before and after. So we can use print on our type and number, and then again we can add in print for our type and number at the end, and we're going to see that it started off as an integer and then we cast it through to a float. So everything is working as expected, but we're now explaining the process explicitly rather than allowing the implicit coercion. It's really your choice, whatever works for you. But perhaps something a little bit more practical where we probably do need to do this is looking at our input dialog box. So let's reassign our number variable and set it to be assigned the value of our input function. Our input function is always going to return a string. I can ask the user to enter the age and I can expect them to put in an integer. However, input will always return a string. We can double check this if I go through and print out our number type at the moment. So if I go through and print out type of our number, it's going to show me that it's str representing a string. Let's hit our command and enter or control and enter. I get my prompt, so I can say, well, you all know that I'm 21. And we can see there that it's a string. So if I needed to do calculations on this, I'm going to have issues. So what we might like to do is convert it or cast it straight away. So if I use the int function, this is going to cast whatever is input through to an integer, so long as it's capable of converting through to an integer. When I go through now and take a look at this, I can say again I'm 21, but you can see now the result coming back is an integer, so I'm happy to work with this. And as always, there are things to note or edge cases that we must take note of. So let's move back through to our Jupyter notebook. And working with our input function, let's run this again, but let's see what happens when we put a float in. Remember that input is going to return a string, but putting in 21.9, we're going to fail to convert to an integer. It's not that we can't convert floats to integers, it's just that it sees the dot as not being a numerical value. So we're now having a problem. We can see or investigate what's happening. Whereas if I go through and put number equals 21.9, now we know that this is going to be a float, but let's double check where we go through and look at the type of our number, and it's going to report back that we are dealing with a float. So no surprises here. Well, okay, let's then go through and try casting this to an integer. So we go integer 21.9, and we can see then that it comes back as an integer without any errors. Well, okay, if it's not any errors, let's see what our number is. When I print out the number now, when we look at the output, it's not 21.9, it's 21. So if we do try casting floats to integers, we're going to lose a little bit of accuracy. We're going to reduce it to just the integer value and lose any of the fraction side of it. Well, okay, if it was failing on a string, let's set it back to a string. And again, you can see now that we're failing to convert the string 21.9 through to an integer. So a string can be converted so long as it only contains numerical values and not decimal places. We can verify this by going back to our cell 18, changing our 21.9 as the string to 21 as a string, and we can see then that that does convert back properly. With our understanding of floats being written as strings to be converted, let's go through and run our input again, but this time let's say we have just typed it as a word, 21. Now obviously this is a string that we can put in, but a string that is not going to convert to an integer, just in the same way as the decimal place couldn't be converted.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.